Hello and доброе утро. The presentation will be in English, но вопросы можно и по-русски, по-украински, я понимаю, так что без проблем. So welcome to the security session. The presentation will be very technical, very in-depth, but it will be covering a lot of topics. So hopefully you will find something interesting for you if you are, into if you are a developer, you are DevOps, you are infrastructure engineer, whatever really. So it should be covering a very broad area of topics. So this will be, just one second. This one I missed. So a few words about my background. I've been in information security industry for a very long time, since 90s. I started from software cracking distributed over FidoNet, uploading over 1,200 baud modems, etc. Then went into PC computers, then first saw internet on the university, then started doing Linux administration on the university, then worked for ISP, and then essentially switched to security completely. And that's how it's all started. Right now, I'm working for as a private contractor. Спасибо. Super. Now I'm working as a private contractor. I have my own information consultancy, information security consultancy. I am Polish, but I live in UK and work for clients from all around Europe. Some of the clients I work for were in the financial industry, Goldman Sachs, HSBC, Aon, a lot of companies. I've seen all kind of application, infrastructure, technologies. Some of them were really scary. And when I saw a pension system written completely in PLSQL and being developed continuously from 90s, I really became concerned about my pension. And I was given a task to secure it. So lots of things, lots of technologies. I was switching context a lot. I'm an active developer. I develop in Python primarily. I know Java pretty well. I develop in C. At the same time, I'm a security guy, which is a really great thing, really, because it allows you to wear different hats depending on what you need. So when you are talking to developers, you can understand the problems that developers are facing on every day, and you are not like an alienated from the development environment like a lot of security people do. They just come with advice which is not really relevant because they don't understand what developers are struggling for. Privately, I'm caver, I do mountains a lot, I do horses. Quite an interesting life. This presentation is available right now on Prezi. So this is the URL, this is the QR code. I will show this at the end once more. If you have any questions, just email me or find me on the social networks. Okay, just give you a second. Okay, let's see if the clicker works. Okay, I just use keys. Его включить можно, да? Отлично. So what this presentation will be about. So because with most of the clients, I'm obviously on NDAs, I cannot speak about the details of their networks. And this is really what I wanted to show. This presentation will be based on my own application where I can reveal all the details and show everything. This is a brief architecture diagram of the web application. It's a website that essentially looks like this. It's a website that scans other websites. It was written originally as a tool to scan for web cookies for the purpose of EU Data Privacy Directive, now for GDPR. And gradually I was adding a lot of features like scanning for flash files, flash cookies, ever cookies, all the other fingerprinting technologies, malware, etc., etc. So it's really a very good research lab because I'm the sole developer of this, I have just a few paying clients, so I'm not very extremely concerned about performance and stuff. It all works on pretty low-end hardware. And it allows me to test all the cool web application security technologies. If you look at the headers, HTTP headers of this website, it's using everything that is currently available. Just because I could do this. This was the front end. The back end, essentially, the whole architecture is based on. Let's try the laser. Yeah. Okay, but the laser doesn't work on the screen. That's okay, I'll just use the finger. So essentially, this is a front-end server. This is a very typical architecture, and NGINX running web applications, Django, Node.js, PHP. I have one very old PHP website, but this is actually very good for this presentation because it demonstrates what you can see in the actual business environment. Django is running under NGINX unit, which is a pretty new technology, but it works very well. I just decided to give it a try, and works brilliantly. And you may see that everywhere is systemd. This will be useful at the later stages of this presentation. Just don't pay any attention about this right now. These are all the security technologies that I'm employing on servers, but we'll discuss this in details. Then this very typical database and caching layer, Redis, Postgres, all typical. And then the actual scanning is being done by a network of workers. There's, depending on the load, there's maybe a few or a few dozens of them. They are being controlled by Celery, which essentially pulls things from Redis, the tasks, and returns the returns to Redis. The workers are written in Python. They are, just a regular Django applications, but the actual website rendering is done by Phantom.js. Phantom.js and occasionally ImageMagick for some special purposes. And this will be actually the key part of the presentation because you can imagine what kind of threats I had to think about. So essentially, if you have this type of setup, what can go wrong? Essentially everything. Because over time, over the last, if you look at the history of all these demons over the last 10 years, almost every single of them had some kind of critical vulnerability discovered and published, remote code executions, all kind of very serious issues that could compromise potentially the whole system from inside. So ImageMagick, very typical remote code execution through specially formatted files. A lot of panic on the industry. I was actually working for a client back then when this vulnerability was published, and they were relying very heavily on ImageMagick, and I had to actually struggle to raise the awareness to show them that this is actual threat, and I'll talk about this in a second. And that one was fixed in 2016, but now we have 2019, and you can see there is still a lot of vulnerabilities being published in ImageMagick, which is good on one side because this means someone is looking at the code and fixing these issues. And ImageMagick is a horrible mess in the source code. It's a mix of very different technologies, very different, image parsers, etc., that not many people really fully understand what is inside the code. They come from different times, from different open source projects that were imported without too much focus on security. So this is exactly what is happening right now. Just a very recent PHP remote code execution. Also, if you were running PHP website, this would have come to a surprise because PHP is quite mature as of today. It's no longer the same scripting language that it was like 10 years ago, but still this type of things are being found. And there are exploits available, excuse me the language, but this is how the developer named it. So that's essentially what I was concerned about. And this is exactly what I have to worry. And this is precisely what I was trying to prevent in the website architecture. Now, you see a lot of daemons here, so all kind of typical web application software. But then every portion of this website written in PHP and the Node.js part and the PHP part and whatever also imports tons of libraries and dependencies. And this is when the fun starts, because if you have a Node.js website, for example, this essentially means when you build the application, NPM or whatever you are using for building your application will import tons of libraries which are essentially published on GitHub or other popular websites. And they are essentially, they are third-party code that you import into your application and you run it eventually. You will run it at the build time, you will run it someone else's code at the testing time, and you'll run third-party code at production as well. So obviously, things happen, and if you have thousands of libraries being published on NPM or PyPy or wherever, statistically, people are trying to backdoor them, and statistically, once in a few years, you will happen to download a backdoor library, even if they are found being spotted quite quickly. People are trying to compromise someone else's libraries. They push, they use type squatting. They use all techniques to backdoor the libraries. This is one example, quite recent, of a backdoored Python library, which is, all of them are trying to send steal passwords or steal your SSH private keys and just essentially send them to some third-party server. This one was intended to run in production essentially when a special request is being sent with a digitally signed command in the HTTP cookie. This application, this code will steal your SSH keys and send them back to a third-party server. Sorry, no, this one was remote code execution. It would just execute some code. And there's plenty of those. So there are risks. And if I hear architects telling me right now about their application being internal, for example, I laugh because you cannot speak about having an internal application if your application is running third-party code somewhere deep in the chain, somewhere in some DMZ or on the build server, on Jenkins, whatever. And traditionally, we've been dealing with this type of issues using SSDLC, which is a great thing. And I spent a fair amount of my professional life teaching people and developers and architects about SSDLC. So essentially, how to write programs securely. There are great standards for those. OWASP ASVS is one that I always recommend, and I have actually contributed to ASVS, and I think it's a great standard. So this way, and using some application security scanners, a few of those which are free are mentioned here, well, except for RIPS, which gone commercial a few years ago. This way, you can make sure your application is, your code that you have written is secure. It's again, you can try to prevent vulnerabilities in third-party libraries by using things like dependency checkers, but you may write a pretty good and pretty secure application today, especially if you are using Django or other modern frameworks. They will care about things like XSS for you automatically. And this, in most cases, you will not really have to worry about those at all. However, this is kind of theory. And in real life, as a DevOps or DevSecOps person, you are not at the freedom, unfortunately, in most cases, to have a project always that is written securely. And there's a lot of reasons for that. Some of them are nonsense, some of them are purely kind of cultural in given organization, and some of them are valid. So for example, if you have a financial institution that is into insurance market, and they are using some kind of third-party module for valuation of loan applications. So if you apply for a credit, they will send your details, your age, salary, place of living, etc., to some black box module that was written by a third-party company that essentially does some research on actual data and machine learning. And this module may be completely closed binary that you get from the company for thousands of dollars, and you have to install it on a very specific version of Linux or Solaris or IX or whatever, and you cannot touch it. You cannot update it, you cannot touch it because this is not covered by the vendor's support, maintenance, etc. So in these cases, you as a DevOps or DevSecOps, you have to actually face a very difficult challenge. You have to ensure that the whole application is secure, even if some parts of this application or the whole application is complete rubbish as it comes to modern web application security standards. And this is a very common situation, a comfortable situation where you have a greenfield project when you have choose, whatever is currently available, the best practices available today for web application security. It's a nice situation, but it's not happening very frequently. And then even if you secure your environment perfectly, it changes. So people are not only deploying new versions of the applications all the time, but new vulnerabilities are being found. So this is, back to the external dependencies. The dependency, the library you are using today may be secure today, but tomorrow there is a critical vulnerability being discovered, like this PHP thing. Or there may be another series of serialization bugs, whatever. There were a lot of these kind of groundbreaking vulnerabilities that essentially destroyed a whole class of applications. Heartbleed 2015 deserializations attacks, a lot of those. So this is dynamic environment. Your application may become insecure, exploitable literally overnight. So I'm sure you know this picture. This is about developers and DevOps, DevOps and DevSecOps, and I modified it a bit because in reality, if you have security people talking about SDLC, building secure applications, the people who actually implement this, and this is usually DevOps actually who do this, or DevSecOps if they have security focus, they have actually take these secure applications, which are secure in a test environment as of today, and make them secure for the next decade or so. And this is precisely what the presentation is about. So I will be talking, this will be very technical, but hopefully it will leave you with some pointers, useful pointers, about how you can confine an application, essentially, to make it secure, even if a critical vulnerability is being discovered in the next tomorrow, in a week, month, even after you are not working in the company anymore. And it still remains secure, at least within some available boundaries. There's a lot of those. So Linux kernel offers enormous amount of these technologies which are not very well explored unless the actual distribution enables them. So as of today, if you have a Linux box, pretty modern, your system will be already using most of those for some of the processes. The problem is that in the environments I've seen, the production environments, they are being used very rarely, simply because people don't know about them, and when they start to find out, it's very messy and very complicated. Well, to some extent it is, but I'll show you what is important and how to use them effectively and quite easily. At the end of the day, what you want to really achieve is to confine your application that if you have a regular user, and you can run a program as a root, and if you run your program that is your, let's say, web application, it will be not able to access the whole system, but just the parts of the system that you explicitly allow it, and nothing else. So this essentially means that if you have a web application written in whatever, PHP, Python, Java, and it's only needing really an incoming TCP connection and outgoing TCP connection to the database, for example, if there is a deserialization attack in Java, in Python, Ruby, etc., it will suddenly not be allowed to execute foreign code. So, I mean, it will execute the code, but the code will be not able to pull all the files from the file system, run an exploit to escalate to root, etc. This is the whole purpose of this exercise. So I will just walk through all these technologies in detail. So traditionally in Linux, the system of permissions we have on files is called DAC, so discretionary access controls, which essentially means you are the owner of the file, you set the permissions for the file, and the permissions are being enforced by the kernel, which essentially decides this user files can be accessed by another process. The discretionary part is in that the owner of the file can set the permissions, which essentially means, which is fine, convenient for users, because the users, they are unpredictable. They do different things. They can, today they can watch a movie, tomorrow they want to download another new application, install a new application. So this is very convenient for them. However, on server environments, you don't want this unpredictability. You want your applications to be as deterministic as possible, and this is precisely where mandatory access controls come into help. So mandatory access controls is exactly the technology you should be and you want to be using on server environments, where the application is running in very strictly defined environment, and you exactly know what the application should be doing, what it should be accessing, and when. So there are two popular mandatory access control systems on Linux. One of them is SC Linux, Security Enhanced Linux, which was developed by NSA, and AppArmor, which was developed by, I think, by Ubuntu projects or Canonical in general. And if you run RPM-based systems, they will normally have C Linux. If you run Ubuntu, you will have AppArmor by default. You can run each of those, but it's essentially, I'm talking about what is available by default. AppArmor is perceived as slightly more user-friendly, easier to use. The policies are based on file names, so file paths. In C Linux, the policies are based on inodes. So essentially, if you replace a file, things can change because the inodes have changed. Now, let's look how it works in real life. It's all sounds complicated, but it's really very simple. In case of AppArmor, the policy for the binary that I was showing a moment ago, it's a very simple C program that whole purpose is to read etc password file. This is the whole policy for this file, which essentially means the program is allowed to execute, to read and memory map itself for the purpose of execution, and that's it. It's not allowed to read anything else in the system. This is precisely why the request to read the etc password file was blocked, because it's not whitelisted here. And that's really it. That's the whole policy for this file. There is a bit more here in this abstraction base. It's allowed to read some files in libraries, directory, etc. But this is the very base of how it works. So this is how you generate the policy. There is a very simple program script written in Python that you essentially run. At the same time, you run the binary that you want to generate a policy for. It will present you with a choice. The file tried to read etc pass w, and are you willing to allow this binary to read the file? You say just no, and that's it. The file will be not whitelisted because it's not a legitimate request. And you end up with a policy which essentially, if you run the binary, you will see logs in the kernel log, the actual entry where it's denied. It's here. It says this binary tried to read this file, and it was prevented from. This is really very simple. You can run the policy on many levels. You can run it in enforce mode, which essentially means it will be actually blocking files. You can run it in complaint mode, which is used for debugging and for building the new policies. You can completely disable it if you run into any problems. They are all simple commands. And at the end of the day, this is the outcome. So obviously, in most cases, we are not really playing with simple binaries. We are playing with large, Java written application, Python applications. But this is exactly how it works. And it's working on like this on every level, even if the binary you are confining runs another binaries. So you can actually tell AppArmor, yes, I want this binary, which can be shell, can be grep, or other system binaries, to inherit all the permissions from the parent level, or you can create a sub-policies for this particular binary. This is very flexible. And if you run a modern Linux distribution, you probably already use AppArmor a lot, because most of the binaries in the system, maybe not most, but a lot of them, come with built-in, from the distribution, they come with AppArmor policies. These are typical system daemons. These are snaps, which are new Ubuntu distribution format, which I'll discuss in details in a second. So AppArmor, that's something you can use straight away on your server, and that's what I'm using on all of my servers right now. Because the policies are simple text files, you can distribute them through anything, through Puppet, Ansible, Chef, Salt, whatever you are using, your tool of choice. And the whole philosophy is about building the policy for your target environment. Make sure that all files are covered, and probably then run the binary for a week or so in complaint mode and watch for any denied messages, because you may have some kind of long running processes. You have cron tasks that run every day or every week or something like that, and run the binary in a way that is not representative for the policy for the modeling that you've run on the first time. At the end of the day, you end up with a system where all the critical daemons are running with enforce mode, AppArmor, and even if they are compromised tomorrow night by some new zero-day remote code execution attack, they will be confined, and the attacker will be not able to get out of the jail, essentially. So this is very, I apply this for all the binaries that I run on workers, on the web servers, etc. And it just works, especially for these two where I'm most concerned about all kind of bugs, because there are complex applications there with a history of vulnerabilities. So the next element that is present in the kernel, in Linux kernel, and this one is not something you want to use directly in most cases, is secomp. It's essentially, you can think of it as a system call firewall filter. So system call is is a function that a binary running in user space calls to access system functions, kernel functions, like configure network interface, but also very simple things like read and write, or open a socket, network socket, bind to it, and accept data on it. Secomp essentially allows you to create a filter, either very simple, where you can only read and write, which is good for a process that only processes data it gets on standard inputs and outputs to standard output. This is the original implementation that was created like 10 years ago. And also, you can create very sophisticated filters that allow you to explicitly describe the system calls that are allowed, not only system calls, but also their arguments, which is very convenient for some users. But as I said, it's not something you want to use directly because it's quite tricky and complicated. So for most of the kernel level things, like which were described on the first screen, all kind of YAMA settings, kernel modules, security, etc., etc. There is a very convenient DevSecIO row, which is available for Ansible, Puppet, and Chef, which you can apply on your server. It will enable all of this, tons of small settings that increase your server security. It can break some things, like, for example, it disables SSH agent forwarding because it's inherently insecure, but in most cases it will not cause any harm. and if you run it on the development server, I run this on my old production servers, and it just works. It doesn't cause any issues. So this is all about all the small settings that we could talk for hours about. So how we do this in real life. So as I said, AppArmor you can apply directly today. It's usable. All the other settings like SecOps, SMAC, etc., they are quite tricky, and if you are developing an application in C that needs to be secure, you can probably consider learning about them a bit more. If you just want to secure your server, you want to use all kinds of wrappers. And the wrappers will make your life much easier. They will use all of these technologies in a very convenient way. So we have kind of two classes of wrappers. We have jails and sandbox applications, which essentially run your application inside the jail, like these programs. And they will enable different technologies depending on what you tell them. So the one that is probably most advanced today is FireGel. It's kind of, I would say, it's most maintained, still developed, and I have actually reported a bug yesterday to it, and the developer replied within an hour, so which is a good sign. And the whole purpose of a jail program is that you can run another program in it, telling it, for example, that you want this program you run inside the jail to be completely, disabled any network communications, and it will do it. So you don't need to really, go into the details how you do this. You don't need to think about AppArmor, SecOps, etc. You just tell it disable network, and that's it. How it does, it's not your worry. It will use all the available technologies to do this securely, which is a very convenient thing. So in FireGel, this is essentially how you run it. That's because I don't specify any command here, it just runs a shell. This command essentially means create a whole new private, isolated environment for this application, which essentially means like a ch root, but on steroids. So it will have the whole file system will be private. It will be it will be discarded after the program finishes. It will have private cache directives, private whole root file system, private dev directory. In etc, it will only have resolve.conf file, which will be copied from the parent one, and private TMP directory. This is the shell, and as you can see, the dev directory contains just a few, strictly necessary devices. etc just contains resolve.conf, TMP is empty, the home directory is empty. So essentially, whatever you run in this kind of jail will be discarded after you finish. But as you have noticed, there was this video 0, video 1 files in the dev environment, so we want to disable it using no video option, and so on and so on. There's a lot of these options. The documentation is very good for this program. The whole point is that these jail programs were kind of originally intended for desktop applications which were plagued by vulnerabilities, like VLC video player, for example. At some point, you could remotely execute code in VLC by sending the user with a specifically crafted video file, etc. So they are kind of designed to run in user space. This is why you have this video, etc. So there are not, you can use them on servers, obviously, but this is not what they were originally designed to. Currently, you can run them on server applications as well. You can configure the policy in a file, not necessarily in a config, in a command line. So this is an example of FireGel policy for transmission, which is a popular BitTorrent daemon. It's a server application or a background application. And all of these options, private etc, for example, are configured here in the file. It does a lot of things. Again, we could talk for hours about what it does and how. You can configure private networks for the process using the bridge interface. The application will just see what you allowed it to, and then you can apply IP tables or NF tables policy to allow or deny traffic from the application to selected networks. You can use NAT to allow traffic into the application running in jail through the bridge interface. And effectively, you can actually run hundreds of these jails on a single server. Each of them will have private network, essentially private everything. It's a bit like a Docker, just much lower profile, using less memory and CPU. So as we go back to our old friend ImageMagick, this is how you run ImageMagick normally, and it's identifies the binary. And this is how you run ImageMagick inside jail with completely disabled network, because obviously I don't want ImageMagick to be doing any outgoing connections. From ImageMagick point of view, it's no difference, unless there is a remote code execution, in which case any attempt to make an external connection will be essentially blocked. Sandstorm.io, it's not another sandbox. It's a very interesting application of a sandbox to deploying web applications. It's essentially a platform where you can pull web applications like WordPress, etc., into a automatically configured jail and run it. It's very simple. I like it because it makes a very practical and very good use technically. I looked into the details how it does it. It's a very good implementation. So if you want to learn how it could be done, on a really good technical level, you can have a look at the source code. It's open source. Docker. Docker is currently a standard, and you may be surprised that I'm not discussing Docker for hours here. But Docker is not strictly a security confinement solution by design. It was designed as a specifically process resource confinement solution to deal with dependencies to create private environments. It does use some security technologies that we mentioned. So it specifically uses C groups to kind of isolate the process into a separate kernel process group. It uses SecOps by default to some extent, and it allows you to use AppArmor, but this is purely optional. So the default policies are quite permissive, so you shouldn't expect too much from it in terms of isolation. And there are existing Docker jail exit technologies. This is one of the exploits that was literally published a couple of months ago, demonstrating how you can escape the Docker jail. As I mentioned, in case of jail, in case of AppArmor, you can easily plug in an AppArmor profile to Docker, and it works. So it's another thing that you can do if your whole environment is based on Docker. Yet another wrapper for the technologies. Snap, a new Ubuntu promoted package distribution format. So it's trying to bring the mobile way of thinking about applications, which are completely isolated, standalone, self-contained binaries that run within its own address space, own file system, digitally signed, etc., into the Linux operating system. And it does it pretty well. It's using internally C groups, AppArmor, SecOps. It also allows you to run service as part of the application. This is how a build file for Snap looks. It's one of my applications, actually, Python application that collects content security policy reports from the web. It runs as a service. It's fully confined by Snap. You could implement the same thing using AppArmor manually, but Snap does it conveniently for you. And as I demonstrated previously, my system, if you install Brave browser and Firefox from Snaps, they will be also running in the jail on your desktop computer. Now, systemd. So there is a lot of argument about systemd. Some people love it, some people hate it. I did not have any strong feelings about it previously, but now I love it because the security features, which are part of default systemd distribution, are really cool. So it allows you to bring all these security features that we just mentioned into single file, single configuration file. Systemd will enforce them on your binary whenever it runs. So I will just quickly run through it because we don't have much time, just to give you pointers for further research. This is again, and now this is actual configuration of a salary worker on my workers, and the security features which are enabled are here. And we'll discuss them in detail in a second. I'll just show them. And this is precisely why I highlighted systemd on all the stages of the architecture. This essentially means that every single process that I run through systemd is confined very strictly through systemd configuration, which is standard, the same, etc. It's easy to configure using Ansible. That's a very powerful thing from DevOps point of view. Dynamic user, a feature that allows you to essentially create a completely separate dynamic user ID and group ID for this particular process. All the data will be discarded. You can save the data if you use few additional options. The application is, run in a temporary environment that will be discarded after you finish. No new privileges. It's just a kind of wrapper for a kernel flag that prevents the application, the process from running SUIT or GUID binaries or SGID binaries. System capabilities. You can allow the process to do something like network configuration, for example, if it's a network configuration daemon. You can enable AppArmor profiles, Linux profiles, and SMAC process profiles, which are another way of doing Mac on Linux. SecOps, again, you can have very friendly groups of syscalls, and this is showing what kind of system calls are allowed for a given group. So it hides all the complexity of syscomp, BPF filters, and all this crap from you. Just use, just allow this, and the process will be allowed to do this. You can do resource controls. You can, nice the process. You can tell the process, the systemd, how much CPU may be used, etc., etc. This is also bound with the C groups. So systemd can run the process in a completely separate C group. You can even allow on systemd level what IP addresses can make connections to this process. Sandboxing, all the flags that we discussed are also available through systemd configuration. So you can, again, implement private network, private TMP, private etc, private everything. And there is a very cool tool, systemd analyze security, which will show you with very nice emojis what system services are running, what kind of confined. Because it's a new tool, as you can see, most of those are not very well protected. But essentially, if you have something that uses has an OK level, this means it's really tip-top. And you can actually look at what suggestions the program makes for your particular system service, what you can enable. So that's essentially why they're all the reasons why I love systemd today. Now we are moving a bit further up the ladder. So essentially, if you have an application like a Java application, for example, and the application is running, you could confine it, okay, using systemd just as well as you can confine any other binary. However, the Java application, the Java virtual machine, does a lot of things that systemd will not be able to see. So obviously, it will be able to see, for example, you can block file system reads using AppArmor, but you will be not able to actually see whether JVM is accessing, some internal structures, etc. It will not detect, SQL injection and stuff like that. because it's all happening inside JVM, and systemd just sees it as a regular system calls being executed. There's nothing going out of the JVM. So RASP is a new technology. It's a very popular marketing name now. There's a few providers that do it. I had a rare opportunity to test it in live, hands-on on one of the banks, and I like it. They are very expensive, so it's a technology that it's not very easy to put your hands on, and it's essentially something that I could in the simplest terms describe as AppArmor for JVM, which is essentially when you have your JVM that runs your Java bytecode, but then you use instrumentation API, which is a part of the new, I think from JVM 8, it's part of the JVM. You apply the RASP policy, and it will be enforcing the policy on the actions of the application. And the policy, in case of one of the products that I tested, which is Waratech, it's very simple, quite intuitive syntax. You can confine file system access, you can confine network access, and it actually has built-in detection for SQL injection attacks. So that's something that is worth testing if you rely heavily on Java applications. It can do much more things. It just, I didn't want to do the presentation purely about RASP. And then there's another thing. You have all these controls and things that you have deployed, jails, etc. And they, by default, are quite verbose. They generate alerts about things happening that you should probably want to know. So if you don't have any alert facility, your system may be secure, but the people who are well motivated to break your system will be trying and trying and trying. So you want to learn about any anomalies as soon as possible. One of the projects that is quite useful here is Linux kernel Runtime Guard. The author describes it as a beta, but I run it in production, it works. So, it's okay. It will notify you about any attempts to modify the kernel structures internally, any unsigned modules loaded, any kernel exploits, etc. It can actually block some of the popular kernel exploits. It will detect them, prevent, kill the process, and alarm you about this. There are two popular exploits that are not very new from the 2017, but some systems are still running these kernel versions. So that's something to try. ODD, it's automatically installed by DevSecIO roles, essentially takes all the alerts from the kernel that are security relevant, and it will display them into, send them to journald or syslog if you need it. It's a very good way of kind of extracting all the security-related alerts from the kernel, and you can actually audit. You can create rules for ODD to audit a specific process, file, system call to alert about every single execution of it. There's a typical ODD log. It's quite verbose, but it's not intended to be read. These are rules. It's not intended to be read manually because you want to have literally 2 minutes. Because you want to have some kind of system that will gather all the inputs from all the critical daemons and put them into one place. So this is Wazoo. It's absolutely fantastic project. I've been deploying this in my clients for the last few years. Currently, I'm working on a really huge project where Wazoo is absolutely key. It's an open source project, so you can contribute to it. And this is what you end up. You end up with a nice Kibana where you have all the relevant attacks displayed in a real time as they happen. You can see what's going on. You can react to it. You can send alerts. It can also do file system integrity checking, so it will notify you about every single file that has changed in the file system. You can whitelist, blacklist, etc. It will notify about known vulnerabilities. So as you can see, one of my servers has plenty of vulnerable kernels, but it's a bit tricky because it checks the file versions, the package versions, and I have the new kernel running in the system, but the old kernel is still installed. So after I clean it, it will stop bothering me about those. And you can hook up Suricata, so network intrusion detection into Wazoo as well, and it will notify about all kind of. So this is my home router. This is when my kids were at home, and there will all kind of Apple crap was connecting to the network, pulling things. After I left for the conference, as you can see, from 31st of October, it's all clean and silent. So Wazoo, strongly recommended, and that's pretty much it. Thank you very much. If you have any questions, yeah. If you need contact or the presentation link, it's here. Any questions?